In this video, I'm going to explain how to segment objects using models built using the StarDist architecture. Here I'm demonstrating how effective StarDist models are at finding objects with the correct settings applied. Before I go into details of how to adjust these settings, let's learn a little bit more about this architecture. StarDist performs instant segmentation. That is, it attempts to identify each example or instance of your objects of interest. StarDist finds star convex polygons. These are objects shaped like spheres or ovoids, or things that would generally be regarded as blob-shaped. StarDist copes well when objects are crowded, and StarDist even copes with a degree of overlap between objects. StarDist can find a single class of objects per model. This architecture was devised by Schmidt and colleagues at the University of Dresden. Let's now return to imagepro. Open the AI prediction panel by clicking on the AI button in the Count Size ribbon. The Deep Learning Prediction panel loads on the right of the application. The panel is organized into 5 simple steps. In step 1, you can click Load to open the model browser and open a model. Here I'm filtering on the StarDist architecture and loading the hematoxylin nuclei model. In step 2, you configure the appearance of segmented objects and choose the class name. In step 3, you select the correct segmentation channel. In step 4, you set the model options. And in step 5, you apply these options and count. Let's now consider the model options in detail, starting with object diameter. You should aim to set the object diameter to match the diameter of your objects of interest. The diameter is displayed in calibrated units for calibrated images, and in pixels for uncalibrated images. This setting comes with a visual guide that shows the currently set diameter. You can click on and move this guide to any location on the image or off the image if you prefer. The guide updates to show changes you make to the diameter field, and the diameter field updates if you change the object size guide by dragging the control points. If you attempt to segment objects with the diameter setting smaller than the diameter of your objects, the results are poor, which is also the case if the diameter is larger than the diameter of your objects. With the diameter set to match the nuclei in this image, the results are excellent. Next, let's look at the threshold setting. Decreasing this value increases the number of predicted objects, at the risk of finding false positives, whereas increasing it reduces the number of objects found, while increasing the probability that every object found is genuine. Here we can see that with the default setting of 69.2, 135 nuclei are found. Decreasing the threshold to 20 results in 162 nuclei being found, including poorly defined objects which probably represent nuclei that are not within the focal plane. Increasing this setting to 80 results in 105 nuclei being found, all of which are well defined and sharply focused. Next, let's consider the max overlap percentage setting. This setting is only applied if the allow overlap setting is enabled. When disabled, pixels can only be part of a single object, and apparently overlapping objects become truncated. When overlap is enabled, pixels can belong to more than one object. With overlap enabled, increasing the maximum overlap percentage allows objects with a greater degree of overlap to be fully segmented. With the default overlap setting of 30, only one of apparently overlapping nuclei, shown here, is found. After increasing the maximum overlap to 72, both of the nuclei are segmented in their entirety. Let's finish this video by looking at options in section 5. Here you can find an option to apply filters and automatic splits. As StarDist is an instant segmentation architecture, finding each instance of an object of interest and separating it from neighbouring and even overlapping objects, filters and splits are seldom useful. Indeed, applying filters and splits is likely to spoil the good work that your StarDist model is doing. This is illustrated by this example, where filters and splits result in some poorly segmented nuclei. Removing the filters and splits option results in the nuclei being correctly segmented. At the bottom of the prediction panel, you'll find links to deep learning related help topics. The content of this video is expanded upon in the troubleshooting prediction section, which I hope you find useful. Thank you for watching this video. If you have any questions, please contact Media Cybernetics and we'll be happy to help.